So did you hear it, Lord? Yeah. Oh, wait, you at the back there. Yes. So I mean, Dev Niyogi came instead of Xinxin, but there isn't anyone here on this very embarrassed. But I mean, we couldn't know that because we didn't get a confirmation that Dev will be here for the fourth presentation. Otherwise, we would have just 15-minute break. But I don't know how the situation is. But if there are people to listen to this, then of course we will have it. Okay. I mean, if we would have known for sure that Deb is here to present, of course we would have waited for kind of 15 minutes. Okay, perfect.
You got some audience now.
Hi. Again. Hi again. Welcome again to the session. Did you follow the last one?
Oh yeah, I'm gonna go to that. That's true. Yeah, he's going to present on their behalf. Where is he? He's collecting people.
Yes. Yes, he will be soon here.
Okay, he's holding people.
Yeah, we didn't know that he will be coming, so we didn't get confirmation. Yeah, I can do it.
Okay, everyone can be seated now. Thank you. This is like my class. Wake up, come forward. We are starting. Lecture is 15 minutes long. Okay.
Welcome to Professor
Thank you.
to give the presentation. Welcome.
Thank you. Okay, good that I am able to talk to you guys. My trip to Sydney now somehow feels more fulfilling. Thank you very much. So we will talk about this study, which has been underway for a few years now, and it essentially comes down to the series of the first global assessment about precipitation changes. And this is a work which will hopefully come out in the proceedings of the National Academy. Marshall Shepard is one of the co-authors. Liang and is Liang and I, we co-advise Xinxin Sui, who is a NASA fellow working on this particular topic. So the premise, as you know, right from early 60s, we have had the whole context of urban rainfall anomaly coming from the so-called Laporte anomaly in Chicago, Indiana region, where you had a place called Laporte, Indiana, which is in northern Indiana, showing an unusually high rainfall maxima. And that rainfall maxima was a subject of a lot of scrutiny, a series of papers of all the places having a debate in science where it was being considered whether it's a fact fiction or whether it is really a feature. Uh, some thought this was an observer who had missed out some data, others thought this is a real process. This also led to the foundation of the creation of the now classic Metromex experiment. So the Metromex was one of the reason Metromex came into picture was to try and address this very issue of whether urban areas actually have an impact on rainfall anomaly. And so Laporte anomaly, as such, led the foundation for what has been the creation of our classic understanding of rainfall changes, where we know that cities, because of the heat island, change the rainfall because of convection. Convection changes your cloud formation changes the rains that are then advected downwind of the city. This is our classic understanding. As we now look at uh, a series of what has come up in terms of the um, urban rainfall studies, we did this meta-analysis that several of you may be aware of, roughly about 1,500 studies that are on this topic, roughly about only 100 which have any quantitative information that can be replicated. And when you start putting all this information together, you start coming up with a scenario which is much different than the classical Laporte anomaly, where you have the urban area changing rainfall downwind of the city. What we do find is that there's a very concrete evidence in the literature that rainfall increases both over the city and downwind of the city. So, depending on the heat island occurrences, there could be rainfall increase over the city or downwind of the city. Typically speaking, when you have a certain high threshold of heat island, then you are going to have a change in the convergence zone, and that convergence zone then changes and creates a rainfall anomaly, which is downwind of the city. On the other hand, when you have a relatively low rainfall heat island occurrences, then you can have an interfacial rain, and that can be over the city. So you have roughly about 20% rainfall increase over the city as well, or it's downwind of city, depending on the kind of heat island effect that exists. So this is one of the things that we had started to look into. Now, given that most of what we have found has been either over one city or has been over the case studies, or it has been climatology over a small region, we have never really had a clear understanding about whether this is a global signature. Now, just the way we have started understanding that urban heat island has a signature which is associated with a temperature pattern, and the temperature pattern is in the global data sets. And so, just like people correct volcano, people correct El Nino in your temperature time series for a global data set, you also correct the urban heat island signature in the temperature. But at this point, there is no correction being done for urban rainfall in terms of our global rainfall data sets. So almost everything then we start seeing is being attributed to the changes in large scale global patterns. So it's the analog there is, as I said, if everything that you're seeing in change of temperature is only being attributed to large scale changes, then imagine the 3 and 4 degree changes that we are seeing in the urban areas could also be attributed to global change, which we know is not right. So that is where we have started to look into this issue. How do we start putting urban rainfall anomaly as a correction factor that can go into the global data sets? So you looked at over 1,000 cities where you have the rainfall data sets that can be reviewed. And from there, we are trying to understand the context of what is the rain over a 20-year period. We identify a region which could start creating the definition of an urban area, first of all, and then what is an urban anomaly region, because for an anomaly, you need urban with reference to another data point. So you have three data points that come up from there. One is the central urban area, which is the impervious surface area, and then you take concentrated distances away from the urban area, which come up with your rural domain 1, 2, and 3. And many studies have shown that it is typically the 2x distance that can be considered as a rural background as compared to the urban when you're looking at the dynamical feedbacks associated with the system. And so then you design and come up with the urban precipitation anomaly, which is your urban rainfall minus the rainfall change in the third domain, R3, that is there. So that will be what we'll be using as a thing. Now, if you have an overlap, then those stations we eliminate and try to look at this separately. I'll not go into that at this point, but that's the setup. So two data sets have been looked at. For the US, we look at the stage 4 data set, and for the global, we looked at iMerged. So before you actually start looking at this, we did a major different rainfall error structure analysis that came out in RSC about what is the error structure in different rainfall products at a global scale. And then it turns out that the iMerge one actually is a pretty much blended one that can be used for creating a good spatial representation that is urban features and other things put in. So let's go into the quick results. So what we find is that 63% of the cities globally have a positive rainfall anomaly. Of that, roughly 85% or 71% in Africa and Oceania region uh, show a consistent rainfall anomaly with regards to an urban rainfall anomaly. So if you're looking at the signatures of the Africa rainfall or the results that are coming up in South America, uh, there's a very strong that is a 60% likelihood that on an average the precipitation anomaly would start showing. Now, this is of course the gross result. Now, if you put this in the context of climate zones, then you start seeing that regions which are tropical and temperate, those are where you start seeing much stronger signature with regards to the rainfall anomaly. The highest rainfall anomalies are in your tropical regions, and then the second one are in the temperate region, relatively speaking. So, dry and continental, you can say, is a much smaller signature. The other thing is, so if not in the climate, you can look at it in the context of the spatial variability, the coast versus inland, because coastal areas we have seen there has been. So the largest precipitation anomaly can be considered in the coastal tropical regions. So cities that are growing in coastal tropical regions are the ones that are showing some of the largest rainfall anomaly going forward. So in the tropical monsoon region and so forth, in hot summers and warm summers. Now, there is a seasonality in the context of what is happening with regards to the um, rain anomaly location, as I mentioned, whether it is over the city, downwind of city, or upwind of city. So here, blue means it's a less anomaly, high anomaly. That means it's wetter conditions, and brown means it is less anomaly. So you can see during spring and summer, you have more wetter conditions downwind, but there are also conditions where it can continue in summertime, particularly. You can see some upwind as well going forward. So, interestingly, when you start looking at the size of the city, the largest upwind anomaly is for the large cities. So, you're going to have the largest upwind anomaly for large cities, especially in the coastal regions, and going forward. So, that would be of effect. So this will be a result which is of interest to Jamie, for instance, who's just walking in, that the large regions, large cities actually show an upwind rainfall anomaly. Small to medium cities start showing more of a downwind anomaly. So that's a global signature that we are seeing. Okay, so lastly, what we are looking at is this is my last slide that if you look at the rainfall for all cities globally, we see that generally the rainfall size, the rainfall anomaly, and the occurrences of wet conditions, whether it is a wet, humid conditions, is a single most important factor that can explain. So, a wet, humid climate with high population density is a direct correlator for high urban precipitation rainfall anomaly into a data set. So this has implications in terms of future changes that can be put through. So what are some of the takeaway messages that we have? First is that urban and its downwind areas receive more rainfall compared to the rural background. That means it is both urban and downwind, not just downwind. We are receiving urban heavy rainfall both places. Larger urban extremes are for coastal and monsoon regions. Local climate, topography, and urbanization extent are clear indicators. The largest one we would say is that the size of the city is really one of the critical factor going forward. So this has implications, as I said, in the manner in which we start correcting our future climate data sets. That right now there is no urban rainfall correction in this data set, but we are seeing a very consistent signature, which could then now go in terms of attribution studies that can go for future when people say our rainfall patterns are changing. With that, I appreciate your coming here and thank you very much.
So are there any questions to Jim? Go ahead.
Um, I have a question about maybe you hinted at this when you were comparing different climate zones, and I imagine different locations, coastal cities, different climate zones have different types of storms. Did you try to separate the precipitation records between like tropical
So,
storms, stuff like
yeah,
that? Yeah.
so the question is almost all these data sets, when you're looking at it, we try to take out these tropical cyclone signatures. So, a certain degree threshold is put in. There's a studies that consider that, and beyond a certain rainfall rate, those data are just taken out into the setup. And there's a separate study, in fact, just to see the effect of tropical storms in urban areas. And there also, the signature actually would be of interest to you. There is an urban signature in the spatial distribution for tropical storms, depending on the cities, that where it rains more. And it's more between the regions where you have two, let's say, two peak cities, where you have tall structures here, tall structures here. That region in between is where you're getting larger signature for rainfall, almost everywhere.
Interesting. Like LA has multiple centers now.
Right.
Just as an add-on comment that I have.
No, you don't.
No.
That's a good question.
Yeah.
So my
Go ahead.
question is like, is there a seasonal signature?
Yep.
Like, does it rain differently in different seasons?
Yep.
You know?
So yes, of course, and that's why I think when it is raining, there is a signature, seasonal signature. I think I show it here, um, about a spring, summer, autumn, winter, and we do see that if you look at summer, it is both upwind and downwind change. More for the autumn and winter, it is a more of a downwind change, and so this is like an indicator of what is happening with regards to the heat island, say, feedback onto the process.
We have time for
Yeah.
questions.
Sir, any information regarding the number of rainy days, like whether they have reduced, like intensity has increased?
Yes. So rainfall intensity clearly has increased over the urban areas. What is the exact number? We are still trying to look into. I mean, if you look at it from the closest Clapeyron setup, we try to look at it from the 16% change. But there is enough evidence to find that it is actually way above that supersaturation rate that is there. So now, whether that can be attributed to the urban heat island because you are going to get, say, 1 degree or 2 degree rise, and does that then correspond within the classes Clapeyron, is the typical way people put it. And when the rainfall is above that threshold, then they say this could be attributed to rainfall. I don't have consistent results at a global scale, but there are cases where it starts showing up quite clearly. Jimmy?
So, sorry, I missed the start of this. Is this for one city or is this everything?
This is 1,000 global cities.
So, but is season really the best diagnosis? It's gotta be something associated with seasons, or something more physically based than just saying it's season,
Right. So the first question is, like a geographer, you would say, are you seeing a change? Then the second question is, what are the factors where we are seeing a confounding change, and we are seeing population, humidity, and so forth. So the change that is being noted, for instance, in terms of the climate regimes. And now comes the question: is the city size or the city direction having a change, coastal versus inland? Coastal is highest change, size of the cities have changed. Now you go into individual scenarios to try and understand the why part, and looks like that's where we are back to our process scale studies. But the objective behind this study was to try to go back that just the way urban temperature, urban heat island is being corrected into global temperature data sets, urban rainfall anomaly is not being corrected in our global rainfall anomaly, global rainfall data sets, and we should start looking into it.
Okay, any other questions? Go ahead.
I have a question. I also want to know how to remove the impact of climate change.
Uh, we can't take out the impact of climate change. I think most studies right now are still struggling with the attribution part of it. That if you have a data over a region, trying to understand whether it is natural variability or whether it is because of climate change is the first order question. But when you're trying to understand whether it is natural variability or
You have
human,
20 years.
well, yeah. So this was because we have 20 year of satellite data set. But the physical principles that we are seeing or the findings that we have now, let us say you have a 100-year data set into the future, where you're talking about urbanization to be changing. So there you have two scenarios already in place: natural variability and greenhouse gas or any other human changes. There is no feature being considered with regards to the urban rainfall changes, especially when it comes to the question of intensity, because it's going to be a localized thermodynamic feedback. And how do we get there? This is a starting point to that.
Okay, if there are no further questions, I think we applause once again.
Thank you. I appreciate all of you coming. Yeah, thank you, John. Enough for setting this up. Nonetheless. Okay. Okay, you guys can go back.
Now we keep you in the room and keep asking you questions.
Yes, of course.
I guess my question really was not necessarily just about extratropical or tropical storms, but more like if you have like a linear system coming through, or just
So the type of storms.
so the dynamics are different for each of these type of storms.
Yeah.
Right?
So if you see our work in Berlin, have you noticed?
I think I have it in my room, but I haven't read it.
I think it can be terrorism.
All right.
There we do.
Okay. Yeah.
So we had Berlin, Indianapolis, Indianapolis also the plus week storm. Berlin was a very nice setup.
Yeah. Well, and I guess because if you get a climate change signal in some types of storms versus others, you might start seeing that the urban signal might get, that's what I was trying to get at that later on. Yeah.
The question that often comes up is, will urbanization intensify or reduce in climate change? And
Right. Yeah.
people say it will reduce, which is a very confusing statement, especially because of warmer areas and cities.
Right.
But the real question here is urban
No,
excess.
there is an email you
Yeah,
do
yeah,
the
yeah.
presentation today.
Thank you for pulling us in.
Of course, yeah. Hello.
There would be technical
I missed
assistance
your
then.
presentation,
Okay,
but
on the next
I would like to
session.
know, do you have publicated paper?
Yes, so if you send me an email, I will forward that to you.
Okay, I can search this.
Yeah.
So you
So I guess
are
the
Xinxin
technician
to
was maybe 15 minutes before the next session here. So if you haven't yet downloaded your presentation.
Yeah.
Presentation here. I assume so.
Yeah, good to see you. Yeah. Where are you now? And then they say, oh, wow. So you're the academy. So what are you working on?
Also, like I couple new game, urban hydrology to couple the work in PNDS. Also do the like climate study, urban climate study.
How are you doing? Very good. So you know Liang, of course, Liang.
Yeah.
So he and I.
I also have a completed paper.
Yes, I know. So he and I continue working on this. So I'm going to go for another session.
I have games for you.
Oh, thank you. How about I take it on your Friday? The day I'm leaving is for Friday.
Oh, that's the oolong tea.
Thank you. You're always so kind.
Thank you for your help in US.
Are you visiting us again? When
I have a talk in the Thursday.
Thursday. Okay, cool.